In this part of the lesson, we need to remember our exponent rules. Whenever you're multiplying two variables with exponents, remember you need to add exponents. Also, remember, if you have an exponent raised to another exponent, you need to multiply them. Those are important rules that you will need to remember. Now, for this time, we want to simplify each rational exponent. So, again, like I said, we're going to need to remember our rules. On your paper, please change it to p to the 1/4 times p to the 9/4. So, to solve this, we have p to the 1/4 times p to the 9/4, so we would actually add the exponents because we're multiplying the variable. So we have p to the 1/4 plus 9/4. We can simplify that a little bit more to p to the 1 plus 9 gives me 10. And remember, when you add fractions, you keep the same denominator. So I would have p to the 10/4. Now I can simplify this one more step, giving me p to the 5/2, because I can divide 2 from the top and bottom here. So my final answer would be p to the 5/2. In our next example, we have r to the -4/5. Oh, it's a negative exponent, so we better put it on the bottom. So we're actually going to have 1 over r to the +4/5 now. Now, for this one, we can't have fractions in the denominator, because actually r to the 4/5 is the same as saying the 5th root of r to the 4th. And we can never have radicals in the denominator. So, to make this more simplified, we actually need to multiply the top and bottom so we can get rid of this exponents in the denominator. So if I multiply both the top and bottom by r to the 1/5, that should work. Whatever I do to the bottom, I have to do to the top. So on the top, 1 times r to the 1/5 just gives me r to the 1/5. And on the bottom, I have r to the 4/5 times r to the 1/5. Well, whenever we multiply, we get r, and then we have to add exponents. 4/5 plus 1/5 is actually 5/5. So, simplifying it one step further, we have r to the 1/5 all over r to the 5/5, or just r to the 1st, which is also just r. We don't have any more radicals or exponents in the denominator, so our answer is completely simplified. So my answer is r to the 1/5 all over r. We need to simplify each rational exponent expression. We're given the problem the 4th root of 32 over the cube root of 2. We want to put these in exponential form. So to do that, the 4th root of 32 is the same as saying 32 to the 1/4 all over 2 to the 1/3. Now, when we have a number over a number, or an exponent over an exponent, we need to subtract the exponents. However, we can't subtract the exponents unless they have the same base. And in this problem, we have 32 and we have 2, but they're not the same base. So we need to figure out if we can convert them to having the same base. So we actually can. So I look at my 32 and I want to figure out if I can get it to say 2 to some power, which gives me 32. And luckily, I know that I can go down the list and do 2 to the 1st power is 2. 2 to the 2nd power is 4. 2 to the 3rd power is 8. 2 to the 4th power is 16. 2 to the 5th power is actually 32. Some of you might have known right away that 2 to the 5th power is 32. So we can actually replace 32 with 2 to the 5th root, still raised to the 1/4 over 2 to the 1/3. So now that we have like bases, we can actually do a little bit more with this problem. So if I simplify the top, remember when you have an exponent raised to an exponent, you multiply. So on the top, I actually have 2 to the 5/4 all over 2 to the 1/3. As you can see, I have similar bases. I both have 2. So I can now simplify this and subtract my powers. So I would be given 2 to the 5/4 minus 1/3. Again, that's one of my exponential rules. So when I subtract these, I actually need to find a like denominator. Remember, go all the way back to simplifying fractions. So I actually can have a like denominator of 12. This one would turn into 4/12, and this one would turn into 15/12. So I still have that common base of 2. 15/12 minus 4/12 is actually 11/12. So I have 2 to the 11/12. Now my last and final step is I actually want to convert it back into radical expressions. So this is actually the 12th root of 2 to the 11th power. And that is my final answer. This next problem gets a little bit trickier. We have the cube root of 16x to the 4th. Now, a lot of you probably would break it down and figure out how many cube roots can go into 16 evenly and how many cube roots can go into x evenly. You can still do that, but in this chapter we actually want to turn it into exponents. So this is the same as saying 16x to the 4th all raised to the 1/3. So I want to put that into each individual piece. So this is the same as saying 16 to the 1/3 times x to the 4 times 1/3. Remember, we need to multiply because it's a power to a power. So this is x to the 4/3. 4 times 1 is 4, all over 3. And we're multiplying those together still. So now we need to simplify it. We don't want to just take 16 to the 1/3 because we don't want any decimal answers. So we want to figure out what something to some power would give us 16 to simplify this. And actually, if we think about it, we want to find something that if we can raise to the 3rd power. So if we actually raise 2 to the 3rd power, we would have 8. 8 goes into 16, and we have 2 left over. So I can say 2 to the 3rd power times 2 gives me 16. We still have that 1/3 power on that 2. And our x to the 4/3 can actually be x to the 3rd power times x to the, we would have 1 left over, so it would actually be x to the 1/3 left over. So, if we take all of these still to the 1/3, we get 2 to the 3rd power, 2 cubed times 1/3 is actually just 2. And then we have 2 to the 1/3 still. So I'm going to put that over here. I have x cubed to the 1/3, which those cancel, and I'm just left with x. I have x to the 1/3, and I'm going to put that over here. So I have 2x, and then my 2 to the 1/3 and my x to the 1/3 are similar. And I actually want to put them back into radical form. So I can also put this back as saying 2x all to the 1/3, because I can't simplify that anymore. And if I were to continue to simplify that down, it would actually be the cube root of 2x. And that's as far as I can simplify it down. So to kind of review this problem, because it's a little bit trickier, we want to figure out how we can break down our 16 to the 1/3 so we can get a whole number out of it. So I broke it down to 2 cubed times 2, which I knew 2 cubed was 8, times 2 gave me 16. 8 times 2 is 16. And I still had that 1/3 times each of them. Same with the x to the 4/3. I knew that x cubed times x to the 1st power would give me x to the 4th, and I still have that 1/3 times both of them. When they cancel, I was left with just a 2x, And then I still had that 2 to the 1/3 times x to the 1/3 remaining. Simplifying that down, my answer is 2x times the cube root of 2x. When we see a problem like this, the first thing we should be thinking is conjugate. So when I have y to the 1/2 plus 2 divided by y to the 1/2 minus 2, I actually want to multiply my first step by the top and bottom by the conjugate of the bottom. So I want to multiply both the top and bottom by y to the 1/2 plus 2. I need to do this because remember, you can't have an exponent in the denominator. Or, another way to look at it is this is actually the square root of y, and we can never have radicals in the denominator. So, to simplify it, we need to get rid of that. So, if I go through the top, I'm going to FOIL it or double distribute it. So I have y to the 1/2 times y to the 1/2, which gives me y. And remember, whenever you multiply, you add exponents. So I have 2 halves. Plus, I would have 2 times y to the 1/2, so 2y to the 1/2. And then I would have 2 times y to the 1/2, so plus 2y to the 1/2. And then lastly, I would have 2 times 2, which is a positive 4. Down below, I would have y and a half times y to the 1/2, which gives me y to the 2 halves, minus 2 times y to the 1/2, which is 2y to the 1/2, plus 2 to the y to the 1/2, minus negative 2 times positive 2 is a negative 4. So, simplifying this down, I get y, 2 over 2 just gives me y to the first power, and remember, you don't have to write the first power down, plus, these simplify, and I can add them together because they have like bases, giving me 4y to the 1/2, and then I still have that positive 4 at the end, all over y to the 2 over 2 can simplify down to 1, and we can just put y. We don't have to have that 1 there. Negative 2y to the 1/2 and a positive 2y to the 1/2 cancel, and then I'm left with a negative 4. Now, once again, my denominator doesn't have any more radicals or exponents, so I know I can be done. So, my final answer is actually just y plus 4y to the 1/2 plus 4 all over y minus 4.